The cube in figure has sides of length L is equal to 10 centimeter. The electric field is uniform, has magnitude E is equal to 4 into 10 to the power of 3 Newton per Coulomb, and is parallel to the xy plane at an angle of 53.1 degrees measured from the positive x-axis towards the positive y-axis. A. What is the electric flux through each of the 6 cube faces S1, S2, S3, S4, S5 and S6? B. What is the total electric flux through all faces of the cube? Given the values, L is equal to 10 centimeter. 1 centimeter is equal to 10 to the power of minus 2 meters. So that is equal to 0.1 meter. And the electric field E is equal to 4 into 10 to the power of 3 Newton per Coulomb. And the electric field angle theta is equal to the angle alpha is equal to the electric field made by the xy plane alpha is equal to 53.1 degrees. This is the alpha. Alpha is the electric field angle made by the xy plane from positive x-axis from the positive x-axis towards the positive y-axis. So this is the given values. We can draw the electric flux through the each faces of the cube. The electric flux phi is equal to E bar dot A bar, where E bar is the electric field and A bar is the area of the vector. That is equal to E A cos theta, where theta is the angle between the electric field and area unit normal vector. The angle between the electric field and area unit normal vector. So this is the theta. We can calculate the electric flux at the surface S1. First of all, we can calculate the electric flux at the surface S1. We can draw the surface S1 in the figure. This is the left side of the cube. We can draw the figure surface S1. This is the surface S1. This is the surface S1 or left side of the cube. Let us take, this is the x-axis and this is the y-axis and this is the z-axis. So the surface S1, this is the surface S1. The surface S1 is the left side of the cube. First of all, the surface S1, this is the surface S1. The area unit normal vector along the perpendicular to the surface S1. So the area unit normal vector is perpendicular to the surface S1. So the thumb direction is indicates the area unit normal vector. Okay, this is the area unit normal vector, A bar or n cap, A bar or n cap. This is the area unit normal vector along the surface, along the parallel to the negative y axis. The area unit normal vector is parallel to the negative y axis. So the angle between this is the angle between the electric field and area unit normal vector is the angle between the electric field and area unit normal vector theta is equal to area unit normal. This is the area unit normal vector and the electric, where alpha is the angle between the electric field to xy plane from x axis to y axis. So this is the direction of the electric field. This is the direction of the electric field. The angle between this is the alpha. This is the electric field E. The angle between the xy plane from the x axis to y axis, where alpha is the angle between the x axis to electric field E is alpha, and we can draw the electric field angle between the electric field and area unit normal vector is, this is the area unit normal vector. So the angle between the this line to the electric field is, this is the theta. The angle between the electric field to area unit normal vector to electric field is the theta. This is the theta. The value of the theta is equal to alpha 90 minus alpha, or 90 plus alpha, where theta is the 90 plus 90 degrees plus alpha, or 90 degrees plus 53.1 degrees. Theta is equal to 90 degrees plus 53.1 degrees is equal to 143.1 degrees. This is the angle between the area unit normal vector to electric field. So the electric flux at the surface S1 is the phi 1. Phi 1 is equal to Ea cos theta, where electric field is the 4 into 10 to the power of 3 Newton per Coulomb into area is the, where area A is equal to L square, where area A is equal to L square. So 0.10 meter whole square into cos theta is the 143.1 degrees. So phi 1 is equal to minus 32 Newton meter square per Coulomb. This is the electric field at the surface S1. This is the electric flux at the surface S1. And consider the electric flux at the surface S2. Another one is the electric flux at the surface S2. The surface S2 is the, from the figure, this is the surface S2 is the upper part of the cube, upper part of the cube. This is the upper part of the cube. This is the surface S2. This is the surface S2. The surface S2 is the upper part of the cube. This is the surface S2. The surface S2 is the upper part of the cube. This is the surface S2. This is the surface S2. The surface S2, the unit normal vector of the surface S2 is perpendicular to the surface. So this is the thumb indicate, the thumb direction is indicates the area unit normal vector of the surface. So the direction of the area unit normal vector A bar is the this direction, upward of the cube. So the angle between the area unit normal vector to electric field is 90 degrees. So alpha theta is equal to 90 degrees. This is the area unit normal vector is parallel to the positive z axis. So the electric field is the electric field along the xy plane. So the angle between the xy plane to z axis is the 90 degrees. So theta is equal to 90 degrees. Finally, the electric flux phi 2 is equal to E A cos 90 degrees. 4 into 10 to the power of 3 Newton per coulomb into 0.1 meter whole square into cos 90 degrees. Phi 2 is equal to 0 because the angle between the electric field to area unit normal vector is perpendicular to each other. So cos 90 is equal to 0. Finally, the flux through the upper part of the surface or S2 surface is the 0. And consider the surface S3. S phi 2 is equal to 0 and consider the surface S3, where surface S3 is the right side of the cube. Draw the figure, the surface S3. Draw the figure, the surface S3. This is the surface S3. This is the surface S3. The surface S3 is the right side of the cube. So this is the surface S3. This is the surface S3. The surface S3 is the right side of the cube. So this is the surface S3. So in this case, the area unit normal vector is perpendicular to the surface. So the surface is perpendicular to the thumb direction is indicated the area unit normal vector. So the direction of the thumb along the positive y axis. So the surface of the area unit normal vector is along the positive y axis. So the direction along the y axis. So the angle between the electric field to y axis is this is the theta. This is the theta. The angle between the electric field to area unit normal vector is the theta. Theta is equal to, this is the angle between the electric field to area unit normal vector, that is equal to 90 degrees minus alpha, that is equal to 90 degrees minus alpha is the 53.1 degrees. So theta is equal to 36 point, where theta is equal to 36.9 degrees. This is the theta, because the electric field along the xy plane. So angle between the x axis to electric field is the alpha, and we can calculate the angle between the y axis to electric field is the 90 minus alpha. So it gives to the theta. So theta is equal to 90 minus alpha, or 90 minus 53.1 degrees is equal to 36.9 degrees. So the electric flux at the surface S3 is the phi 3. Phi 3 is equal to EA cos theta. The electric field E is equal to 4 into 10 to the power of 3 Newton per coulomb into area is the L square, 0.1 meter whole square, 0.1 meter whole square into cos 36.9 degrees. So the electric flux at the surface S3 is the F3. F3 is equal to 32 Newton meter square per coulomb. This is the electric flux at the surface S3. This is the electric flux at the surface S3. And another one, calculate the electric flux at the surface S4. Draw the figure, the surface S4. Draw the figure, the surface S4. This is the surface S4. This is the surface S4. This is the surface S4. So this is the surface S4. The surface S4 are the downward of the cube. Downward of the cube. This is the surface S4. So the unit normal vector, draw the unit normal vector. The unit normal vector is the downwards of the cube. So the unit normal vector is perpendicular to the surface. So the unit normal vector is indicates the direction of the thumb. So this is the direction of the thumb, downwards to the cube or negative z axis. So the electric field toward the negative z axis. This is the, so the angle between the electric field to area unit normal vector is 90 degrees or 270 degrees. So consider the surface S4 where theta is equal to 270 degrees. The angle between the electric field to area unit normal vector at the surface S4. The surface S4 is this is the surface S4. So the unit normal vector is downwards to the surface S4. So toward the thumb direction is indicated toward the unit normal vector. So angle between the electric field to unit normal vector is theta is equal to 270 degrees. So the electric field, the electric flux at the surface 5,4 is equal to E, value of the E is equal to 4 into 10 to the power of 3 Newton per Coulomb into area is the 0.1 meter whole square into cos theta is 270 degrees. So cos 270 is equal to 0. So the electric flux at the surface S4 is equal to 0. This is the surface S4. And we can calculate the surface S5. This is the surface, we can calculate the surface S5, where surface S5 is the front of the cube. This is the surface S5. 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 So the unit normal, the surface S5 is parallel to the x-axis. So the surface S5 is the parallel to the x-axis. So the unit normal vector is perpendicular to the x-axis. So this is the unit normal vector is perpendicular to the x-axis. So this is the thumb indicates the unit normal vector direction. So the angle between the unit normal vector, this is the unit normal vector, this is the unit normal vector. The unit normal vector is the parallel to the x-axis. So the angle between the unit normal vector to electric field is theta is equal to alpha, that is equal to 53.1 degrees, because this is the front of the cube. So the unit normal vector is parallel to the unit normal vector is parallel to the x-axis. So the x-axis, the angle between the electric field to x-axis is the alpha. So the angle between the electric field to the unit normal vector is also alpha. So alpha is equal to 53.1 degrees. So the electric flux at that surface S5 is the 5 is equal to 5 is equal to the electric field is the 4 into 10 to the power of 3 Newton per Coulomb into the area is the 0.1 meter whole square into cos the theta is the 53.1 degrees. So the electric flux at the surface S5 is 24 Newton meter square per Coulomb square. So this is the electric flux at the surface S5 or front of the cube, and the electric flux at the surface S6, the electric flux at the surface x6. The surface x6 is the back side of the cube. So this is the surface x6, this is the back side of the cube. So this is the surface S6, this is the back side of the cube. So the unit normal vector is perpendicular to the this surface. So the direction of the unit normal vector is the along the negative x axis, along the negative x axis. So the unit normal vector, this is the surface, this is the surface S6, this is the back side of the cube, and the unit normal vector is perpendicular to the x axis. So this is the unit normal vector, this is the perpendicular to the x axis. So this is the unit normal vector A bar. So the angle between the unit normal vector to the electric field is, so the angle between the negative x axis to the electric field is, negative x axis to the electric field is theta is equal to 180 degrees minus alpha. Theta is equal to 180 degrees minus alpha, that is equal to 180 degrees minus 53.1 degree. So theta is equal to 126.9 degrees. This is the angle between the electric field to surface S6, electric field to surface S6. This is the angle between the electric field to unit normal vector. So the electric flux at the surface is phi 6. Phi 6 is the electric flux at the surface S6. So phi 6 is equal to, electric field is the 4 into 10 to the power of 3 Newton per Coulomb into area is the 0.1 meter whole square into cos 126.9 degrees. So phi 6 is equal to the electric field, the electric flux at the surface S6 is the minus 24 Newton meter square per Coulomb. This is the electric flux at the surface S6 or back side of the cube. This is the total electric flux. We can find the part B. The part B is the total electric flux in the cube. So the electric flux, the total electric flux phi is equal to phi 1 plus phi 2 plus phi 3 plus phi 4 plus phi 5 plus phi 6. This is the sum of the individual electric flux through the each surface, the sum of the individual flux through the each surface. So the electric flux phi is equal to, where phi 1 is the value of the phi 1 is minus 32 Newton meter square per Coulomb plus phi 2. Phi 2 is the 0 plus phi 3, where phi 3 is 32 Newton meter square per Coulomb. Phi 4 is the 0 plus 5 is the plus 24 Newton meter square per Coulomb plus phi 6 is the minus 24 Newton meter square per Coulomb. So phi is equal to the sum of the electric flux through each surface is 0. The total flux through the cube is 0, because the total flux through the cube must be 0. Any flux entering to the cube must be also leaving it. Since the flux is uniform, So our calculation is given to the result. The sum of the fluxes calculated in the part A is 0. So the total flux is 0.